Example number 1. Find an equation of the tangent line to the parabola y equal to x squared at the point P 1, 1. The question is find the equation of a line. In algebra, we learned that y minus y1 equal mx minus x1. x1 and y1 is a point, which is point P, x1 and y1. So we can plug in the point P for this formula. The problem is we do not have the slope, and we also learned from algebra that the slope is y2 minus y1 over x2 minus x1. So the problem is we need to have 2 points to find the slope. We only have 1 point, which is the point P. Then we need to have 1 more point. Let's go to the graph and look at this. From the point P, we can draw the tangent line like this. But we only have 1 point P. We can not find the slope. So what we're going to do is we will find the point Q on the parabola. The coordinate of this point Q is x, x squared. We get this because we plug x into the parabola. The y part will be x squared. And then we connect the point P and Q. This line we call the secant line. We will use the slope of the secant line to approximate the slope of the tangent line. So first of all, I need to find the slope of the line PQ. Now let me plug in y2 and x2, which is the point Q. That will be x squared minus 1 and then x minus 1. So then I will approximate the point Q. This is the x part of the point Q, and this is the slope of the secant line PQ. We're going to choose the point Q such that it's close to the point P. So the point P is 1, close to 1 is 2. Or 0, right? So what if the point Q is 2 on the x? The y part will be 4. Then the slope of the secant line PQ will be 4 minus 1 divided by 2 minus 1. Then we get 3 over 1 is 3. What if the point Q is 0? Then the y part is 0. Then the slope of the secant line is 0 minus 1, 0 minus 1. So we got the answer is 1. Then what if the point Q is 1.5? The y part is 2.25. Then the secant line PQ has the slope is 2.25 minus 1, 1.5 minus 1. And we will get the answer is 2.5. We continue the process. We will make the x part of the point Q close and close more to 1. Then we get the slope of the secant line is 2.1, 2.01, 2.001. If you notice that they are the number that more than 1, now I want to approximate the point Q that is less than 1. Less than 1 is 0, is 0 0.5, 0 0.9, 0 0.99, 0 0.999. And then I follow the same process to find the slope of the secant line is 1.5, 1.9, 1.99 and 1.999. Now if you notice that the more that the point Q close more to the point P, the slope approaches more to 1. Sorry, the slope approaches more to 2. So you can make the conclusion that the slope of the second line PQ is 2. And this is how do we write in this problem is that the limit when the point Q approaches closer to the point P, the slope of the second line PQ will approach to some number. And to be more clear, we said that the limit of when the point Q, which is some x value, approach to 1 on the x value of the point P of the slope. The slope in general is x squared minus 1 divided by x minus 1. Right here, right? And is equal to 2. So the slope of the second line approach to 2, and we can say that the slope of the tangent line is 2. Now we go back to the equation. We plug 2 into this equation, and we open parentheses, combine line term, and we solve for y. We will get the equation of the tangent line will be y equal to x minus 1.